You know how your phone just magically recognizes your face? Or how a streaming service knows exactly the movie you're in the mood for? Well, that's not magic. It's an incredible technology called deep learning. And today, we're going to pull back the curtain and demystify it. First things first, deep learning isn't some far-off science fiction idea. Nope, it's already here, woven right into the fabric of our everyday lives. It's behind the music you listen to, the photos you take, even the safety features in your car. I mean, just think about it. You type something into a search bar and you get the perfect result. You open up a shopping app and it shows you exactly what you were looking for. It all feels so seamless, like these systems just get us. So what's the engine driving all of this? Okay, this is where it gets really interesting. The true breakthrough with deep learning isn't just what it does, but how it does it. It's a total shift in how we think about building intelligent machines. This slide really says it all. See, the old way, on the left, meant a human expert had to sit down and hand code all the rules. To find a cat, you'd have to tell the computer, look for pointy ears, look for whiskers. But with deep learning, on the right, you just dump in thousands and thousands of cat photos, and it figures out what makes a cat, all on its own. And this whole idea of a machine learning directly from raw data, it has a name: representation learning. And the deep part of deep learning? Well, that's just because it learns these representations in layers, lots and lots of layers, with each one building on the one before it to create more complex concepts. And here's a perfect look at how that layering works. The system doesn't just see a dog. At first, the bottom layer sees nothing but raw pixels. The next layer up learns to spot simple things like edges and colors. Then a layer above that combines those edges into motifs, like an eye or a nose or the texture of fur. It keeps going, putting the parts together until that top layer can confidently say, yep, that's a Samoyed. It literally builds understanding from the ground up. So this is the absolute key. Nobody, not a single human engineer, told the machine to look for edges or noses. The entire hierarchy, all those layers of features, are learned automatically straight from the data itself. That right there, that's the revolution. All right, so we get that it learns in layers. But how does that training process actually happen? How does the machine tweak itself to get better and better? Let's pop the hood and take a quick look. The most common way is something called supervised learning. It's basically a simple loop. First, you give the machine a giant data set where all the right answers are already labeled. Then you show it an image and it makes a guess. You have a way to measure its error, basically how wrong it was. And based on that error, the machine adjusts its internal settings just a tiny bit. You do this millions of times, and each time it gets a little bit smarter. And when I say it adjusts its settings, we're not talking about a few dials here. We're talking about an absolutely mind-boggling number of them. Think of them as tiny little knobs. A modern deep learning system can have hundreds of millions of these knobs, or weights, all being tuned at the same time. The sheer scale is what gives it so much power. So with millions of knobs to turn, how does the machine know which way to turn them? Well, here's a fantastic analogy. Imagine the machine is a blindfolded hiker standing in a huge, hilly landscape. The height of the ground at any point represents the amount of error. The goal? To find the absolute lowest point, the bottom of the deepest valley, where the error is basically zero. So how does our hiker find their way down? Through an amazing process called backpropagation. Every time the machine gets an answer wrong, an error signal is sent backward through all those layers. It's like a whisper that tells every single one of those millions of knobs which way is downhill, how to adjust itself just a tiny bit to lower the total error. It's the core engine that allows the network to learn from its mistakes. Okay, so now we know how these things learn. But deep learning isn't just one single tool. It's more like a whole toolkit with specialized architectures built for different kinds of problems. When it comes to processing images, video, or really any data that's laid out in a grid, the undisputed champ is the convolutional neural network, or what everyone calls a convnet. What's really cool is that its architecture was actually inspired by how the human visual cortex is structured, which makes it just brilliant at finding patterns in visual information. Now, convents had been around for a while, but 2012, that was their big moment. There's a famous annual competition called ImageNet, and that year, a deep convet didn't just win, it absolutely destroyed the competition. It nearly cut the error rates of the best previous systems in half. That single event kicked off a revolution in computer vision that's still going on today.
But what about data where the order of things is super important, like words in a sentence or notes in a song? For that, we turn to a different tool, recurrent neural networks, or RNNs. The simple way to think about them is that they have a kind of short-term memory. As they read a sentence word by word, they remember what came before, and that context is everything for understanding the meaning of the whole sequence.
And here's where it gets really powerful. We can actually combine these specialized tools. Check this out. This system uses a convon net to see what's in the image. It identifies the giraffe, the trees, the setting. Then it feeds that understanding to an RNN, which uses its memory of language to write a descriptive sentence. It's this incredible fusion of artificial sight and language. For an RNN to make sense of language, it can't just treat words as, well, words. Instead, it learns to place them on a giant, complex map, a semantic space. On this map, words that have similar meanings like king and queen or walking and running are positioned close to each other. This lets the model understand the relationships between concepts, not just the words themselves. So we've covered a ton of ground, from how these systems are trained to the different tools they use. But where's all this headed? What's the next big frontier for deep learning? This quote just nails the next huge challenge. Pretty much everything we've talked about so far is supervised learning, where we have to spoon-feed the machine millions of labeled examples. But that's not how we learn, is it? We learn by just looking around and observing the world. And getting machines to do that, that's the push toward unsupervised learning. This really is the cutting edge. Unsupervised learning is a huge focus, where the AI finds the patterns all by itself. Then there's reinforcement learning, where an AI learns by trial and error, like you would learning a video game. And the ultimate goal for many is to combine this incredible ability to recognize patterns with the power to reason and think through complex, multi-step problems. So we've gone from the basics of deep learning right up to the frontiers of AI research. And it all leaves us with a pretty fascinating question to chew on. As these incredibly powerful systems start learning about the world more like we do, not from our labels, but just from pure observation, what new patterns, what new connections, and what new insights about our own world might they end up showing us?